Firstly, I will start with introduction of Large Hadron Collider. Large Hadron Collider (LHC) is the world's largest and most powerful particle accelerator and a scientific instrument of extraordinary complexity. It was built by the Europe Organization for Nuclear Research between 1998 and 2008 in collaboration with over 10,000 scientists and hundreds of universities and laboratories across more than 100 countries. It lies in a tunnel 27 km in circumference and as deep as 175 meters beneath the France-Switzerland border near Geneva. Its primary function is to use electric field to force change particles to move at very high speed, move and still keep under control. The LCD was designed to explore of matter by colliding particles and extremely high energy. The Large Hadron Collider aim is to allow physics to test the predicted of different theories of particle physics, high energy physics, and in particular to prove and disprove the existence of the theories high boson and the large family of new particles predicted by supersymmetric theories. The HSC is expected to address some of the most fundamental questions of the physics, advancing human understanding of the deepest law of nature.
Hi, Assalamualaikum. My name is Nur Amira binti Mansur, S72008. Concept Basic Theory of Physics. The Large Hadron Collider LHC uses quantum chromodynamic QCD, which describes the strong nuclear force that bind quarks together to form protons, neutrons, and other hadrons. In quantum chromodynamic QCD, quarks are the fundamental building unit of matter, whereas gluons are the force carriers that mediate the strong force. Quarks and gluons bind together, form protons and neutrons. A crucial notion in OCD is color charge, which is similar to electric charge in electromagnetism but has three types: red, green, and blue. QCD has a unique feature that makes it distinct. One is confinement, where quarks and gluons cannot exist freely and are always confined within hadrons as the force increases with distance. Another asymptotic freedom, where the strong force becomes weaker at very high energies or short distance, allowing quarks to behave almost as a free particles. These principles are crucial for understanding the high-energy interaction studied at the Large Hadron Collider. QCD is used at LHC to describe the predicted dynamic of proton collision, in which quark and gluon, known as batrons, interact at extremely high energies. The Lagrangian encapsulates the mathematical framework of QCD, which includes terms for quark field, covariant derivative, incorporating gluon, the gluon field strength tensor, and quark mass as shown in figure. These Lagrangians serve as the basis for all QCD predictions and calculation. QCD application at the LHC allow to precise modeling of high-energy collisions, with prediction tested against experimental data to refine our understanding of the strong force and potential uncover new physics. That's all for me.
In this part, I will explain a concept, the basic of physics, used in development or manufacturing. Firstly, concept mechanics is a part of physics that looks at how things move and the force involved. Engineers use this to design buildings, vehicles, and machines. For example, Newton's law helped them figure out the force and loads in their design. Next, concept thermodynamics involves the study of heat and energy transfer. Engineers use its law to design engines, power plant, and cooling systems. And then, concept electromagnetism involves the interaction between electricity and magnetism. This concept is crucial in modern technology.
Next, I will continue about concept, the basic of physics used in development or manufacturing. For the next point, I will explain about fluid dynamics. Fluid dynamics helps design systems like liquid transport, wind, turbines, and vehicles for better efficiency. It's used in cooling heavy machines and powering hydraulic equipment like cranes and excavators. Furthermore, the fifth point is material science or solid-state physics. Material science helps engineers develop strong, lightweight, and corrosion-resistant materials used in cars, planes, and electronics. These materials also guide manufacturing methods like casting, pressing, or 3D printing. Understanding how materials behave at the atomic level helps create better, more eco-friendly options. The last one is acoustic. Acoustic physics help control noise, design audio devices, and use ultrasonic wave in industries. In manufacturing, ultrasonic wave clean small parts and check material for defects without damage or ensuring high product quality. That's all. Wait for the next point.
And now, I want to present my point. My point is how the principal application works. First point is particle acceleration. RF cavities. These cavities use electric field to speed up particles like proton. Superconducting magnet. Powerful magnet bend the particle path and keep them in a circular orbit. Second point is particle collisions. Bunch of particles. Proton travel in bunch in opposite direction. Collisions. The particle collide at specific point where detector, for example, Atlas and CMS, capture the result of this high energy crash. Third point is detection and measurement. Inner detector. Inner detector track the path of charged particles. Colorimeter. Colorimeter measure particle energy. Muon detector. Muon detector detect heavy particle called muons. This detector helps scientists study the particle produced in the collisions. The last one is data analysis. After collisions, the data is sent to supercomputer for analysis. Scientists use the data to test theory in physics, like the standard model in IDs beyond it. For example, is supersymmetry. That's all. Thank you.
Lastly, for conclusion, the Large Hadron Collider gained a considerable amount of attention from outside the scientific community, and its progress is followed by the most popular science media. It has significantly advanced our understanding of the universe by providing experimental evidence for fundamental physics theories, such as the higher boson. The LHC has also sparked the imagination of outdoor of-world of fission, although description and projected outcomes of the experiment are often only vaguely accurate, occasionally causing concern among the general public. As we look to the future, the LHC has luminosity upgrade and extend operational timeline promise to unlock even more mysteries of the universe and delve into rare process. The LHC impact extend beyond particle physics, driving technological advancement and inspiring to the next generation of scientists. We can also develop new particles which will be helpful for making new matter.